Hi, my name is Aaron Daniels, and for my Creature and Adventure Lab, I decided to model the motion of the Earth's moon around the sun. What initially sparked my interest in this topic was a friend of mine asked if there was ever a possible scenario that one full Earth rotation we did not see the moon. I looked up the moon's orbital speed and found that it orbits the Earth every 27 days. So the answer to that question is obviously no, we will always physically see the moon for an entire day, at least once. So instead I decided to create a model for the moon's orbit around the sun. I was inspired by this YouTube video. Which would lead you to believe that the path of the lunar orbit looked something like this. So instead, I decided to model this and see if this was true for myself. I found out that the lunar orbit does not look like this, and in fact looks completely different. So I created my own Vpython model. I set up the scene and created the sun, the moon, and the earth. In order to follow both the motion of the earth and the motion of the moon, I created two trails. I looked up the proper statistics online and found the mass of the sun to be around 1.989 times 10 to the 30th kilograms. The mass of the moon was around 7.34 times 10 to the 22 kilograms, and Earth was about 5.972 times 10 to the 24 kilograms. I put the sun in the center and found the distance of the moon and the Earth away from the sun, and set that as the initial position along the x-axis. I also found the initial velocity of the Earth. Actually, in order to find the initial position of the moon, I found the distance of the moon from the Earth and added that to the distance of the Earth from the sun. I used a similar method for velocities. I found the Earth's velocity around the sun, and then I added that velocity to the velocity of the moon around the Earth for the moon's initial velocity. I also set the gravitational constant to 6.7 e to the negative 11. Then, using this function I made to update the position of the planet, I was able to update the position for Earth, and I used a similar process for the moon. I had to use momentum principle and energy principle to find these calculations. In order to focus on the moon's motion, I made the center of the scene the Earth, so in the while loop, I put this line here so that it always followed the Earth, and that way all we had to do was zoom in to see the path of the moon. So here it goes. The blue line represents the moon's path, the red line represents the Earth's. So if we zoom in here, we can see how the moon is moving around the Earth. And if we zoom out, we can see the Earth and Moon's paths around the Sun, which I found to be really cool. If you zoom in, you'll see that the Moon's path changes from the path that it took the last year. It's in a completely different position than when it was in the same general area from the previous year. So to conclude, yes, it is possible to model the motion of the moon around the sun. However, if you have noticed, there have been points where it would appear like the moon is hitting the Earth and going through the Earth. That is due to initial settings. So in order to find the actual motion of the moon around the Earth, around the sun, obviously more variables need to be taken into account for, and better start data is needed to model this problem. Thanks, I hope you enjoyed it. Hope to see you soon.